Hello students. Today we learn in electronic science paper 5th chapter 2nd Fourier series and its applications. The Fourier series, and it is a definition of Fourier series: coefficients, triangular wave, square wave, sawtooth wave, half adder and full adder rectifiers. Now, in MATLAB, Fourier coefficients and the given functions of the waveforms. We will discuss in these parts in these lectures. Now, then what is the Fourier series? The Fourier series is the Taylor series. It is represents the functions like as the sine wave, square wave, triangular wave. This is the continuous waves and its differentiables. Then these discontinuous periodic functions, it requires the two series, that is the two infinite series, sine and cosine terms. It is depends on the Fourier series only the functions of sine and the cosines values or the terms. Now the periodic functions, it is a functions of discontinuous values and the derivatives of these functions. Then the Fourier series is the very powerful methods, and we will solve the ordinary and the partial differential equations. Now next, what is the Fourier series? Then definition of the Fourier series is: Fourier series is a periodic functions as compared to the harmonically related to sinusoidal signals. In terms of the infinite sines and the cosines waves, it is the orthogonally relationship of the sines and the cosine functions. This is the definitions of the Fourier series. It only depends on sines functions and the cosines functions. Then the equations can be written as in the Fourier series: f of x is equal to 1 upon 2 a0 plus summation of n is equal to n to infinity an cos nx plus summation of n is equal to 1 to infinity bn sin n of x. Now we denote the a0, that means 1 upon pi integration of minus pi to pi f of x dx. An indicates 1 upon pi integration of minus pi to pi f of x cos n of x dx, and bn is equal to 1 upon pi integration of minus x into x minus pi to pi f of x sin n of x into dx. That means the functions of a0, an, bn, it is the main functions of the Fourier series, and these functions, it depends on the orthogonally relationship of the sines and the cosines waves. Then advantages of the Fourier series is the representations of discontinuous functions. That is the very important advantages of the Taylor series. We can represent the discontinuous functions, for example sawtooth waves, by the Fourier series. Then the Taylor series, it represents the continuous functions. The coefficients can be obtained by the successive derivative of functions. That's why the periodic functions are not continuous or not differentiables. Then next advantage is the representation of periodic functions. Periodic functions to represent in the Fourier series, it is the even and odd functions. This is the main parts of the functions, and it can be expressed by the sines and cosine series respectively. This is the advantages of Fourier functions. Now then we will first discuss even and odd functions. Fourier series for the even and odd functions. The even and odd functions is the functions f of x, it can be even. Then the period functions is minus L is less than is equal to x is less than is equal to L. Then f of x cos n pi x upon L is the even, while f of x sin n pi x upon L is the odd function. That means, in short, to remember that cos x is the even functions and sin x is the odd functions. Now the Fourier series expansions of the even periodic functions f of x is equal to a0 upon 2 summation of n is equal to 1 to infinity a n cos pi n x upon L. Now a0 it denotes the 2 upon L integration of 0 to L f of x dx, and an is equal to 2 upon L integration of 0 to L f of x cos n pi x dx, n is equal to number of terms. Now bn is equal to 0. Why bn is equal to 0? Because we only write these functions, it is a even functions. Even functions is write as the cos x or the cos terms. Now next is the odd functions. Odd functions, it is remember that the sine functions. Then f of x is the even periodic functions, that the functions we can write here f of x is equal to summation of n is equal to 1 raised to infinity bn sin n pi x upon L. That is bn is equal to these terms 2 upon L 0 to integration of 0 to L f of x sin n pi x upon L into dx. This is the odd functions. Then example for the even and odd functions of the Fourier series. First, to find the Fourier series, f of x is equal to x square plus x. Only these equations gives. Then to find out the Fourier series. Then the Fourier series f of x is formula for the Fourier series f of x is equal to 1 upon 2 a0 plus summation of n is equal to 1 raised to infinity an cos nx plus summation of n is equal to 1 to infinity bn sin n of x. A0 denotes by using the formula a0 is equal to 1 upon pi integration of minus pi to pi f of x dx. That is f of x value is given x square plus xs. Put this value in the a0 equations. Then we get 1 upon pi integration of minus pi to pi x square plus x dx. That integrations, take integrations on these equations, then x square integration is x cube by 3 and x integration is x square by divided by 2 minus pi to pi. This is the integration. Then 1 upon pi in these terms, put the value of minus pi to pi, then this equation gives 1 upon pi cube divided by 3 plus pi square divided by 2 plus pi cube divided by 3 minus pi square divided by 2. Put the value of minus pi to pi, then is equal to 2 pi cube divided by 3. This is the a0's value is given. Then find the an. An is the even functions, that is the cos nx. Then 1 upon pi integration of minus pi to pi f of x cos nx dx. Then 1 upon pi, take the integrations minus pi to pi, put the value of f of x is the x square plus x into cos nx dx. Then 1 upon pi x square, by using the multiplication rule x square plus x into cos nx. The formula for a into b dx, the integration of a into b, first condition a it is remains constant, integration of b minus b is constant, then take the integration of first in these parts, then integration of first term is a constant x square plus x, then integration of cos nx dx is the sin nx divided by n. This is the first point. Then plus minus multiplication, this is the minus sign. Then x square plus x, this is the integration of 2x plus 1 into cos nx integration minus cos nx upon n square plus 2 into minus sin nx divided by n cube, 2 minus pi to pi. Then solve these equations. 2 1 upon pi, 2 pi plus 1 cos nx n pi divided by n square minus of minus 2 pi plus 1 cos n pi upon n square, that is suppose the value of x is equal to pi or minus pi. Then 1 upon pi is equal to 2 pi plus 1 minus 1 n square raised to n or divided by n square minus in bracket minus 2 pi plus 1 into minus 1 raised to n divided by n square. Then 4 into minus 1 raised to n divided by n square. Then similarly to find the Bn values 1 upon pi integration of minus pi to pi f of x sin nx dx. Take the integrations this part by take the parts, then value is equal to 2 minus 1 raised to n divided by n, that is the Fourier series as f of x is equal to x square plus x. Then x square plus x is equal to first condition a0 is equal to value we will find pi square divided by 3 plus summation of n is equal to 1 raised to infinity. Then in square bracket 4 minus 1 raised to n upon n square cos nx, this is the value of an minus 2 into minus 1 raised to n divided by n sin nx, this is the value of Bn. This is the formula for, or is the series for series of Fourier series of functions f of x. Then next is the applications of the Fourier series. The applications of the Fourier series, it is the square wave, triangular wave and sawtooth waves. Then first is the periodic functions. The periodic functions is the f of x or the f of theta is a periodic. Then it is defined as the real and it is some positive numbers. The positive numbers, then f of theta plus t is equal to f of theta. Then formula for the periodic functions or the trigonometric functions by taking about f of theta is equal to or f of x is equal to a0 summation of n is equal to 1 raised to infinity an cos n theta plus summation of n is equal to 1 to infinity bn sin theta. This is the equation for the trigonometric functions, that is cos theta, cos 2 theta, cos 3 theta. It is the functions for the even functions, and sin theta, sin 2 theta, sin 3 theta is the odd functions. Then example for the periodic functions, find the Fourier series of the following periodic functions. This is the square wave. Now this equations gives f of theta is equal to a when 0 is less than theta is less than pi or is equal to minus a when pi is less than theta is less than 2 pi. Then f of theta plus 2 pi is equal to f of theta. Solve these equations. A0 is equal to 1 upon 2 pi by take the integration first part 0 to pi or 0 to 2 pi, that is the 0. These conditions like show this first square wave up to 2 pi, that is first integration is the 0 to 2 pi f of theta d theta. Then put the value of theta or the 2 pi, 1 upon 2 pi is a common integration by first 0 to pi. First condition by integration 0 to pi, second is the pi to 2 pi. Then first condition 0 to pi f of theta d theta plus integration of pi to 2 pi f of theta d theta. Then 1 upon pi integration of f of theta is the a 0 to pi a d theta and pi to 2 pi minus a d theta. Minus sign indicates that the square wave downside is the minus a indicate, and plus sign indicate is the plus a or the sign plus. Then by the integrations of this side is the 0, then 1 upon 2 pi into 0 is equal to 0, then a0 is equal to 0. Now next find is the an 1 upon 2 pi integration of 0 to 2 pi f of theta cos n theta. Then take the integrations by 0 to pi, pi to 2 pi. Then first condition is a positive, second is a negative, a cos n theta d theta minus a cos n theta d theta. Then integrations of first in part, a is a constant, cos n theta integration is the sin n theta divided by n 0 to 2 pi plus 1 upon pi, it is a separate, minus a, it is a constant, then cos n theta is equal to sin n theta divided by n, pi to 2 pi is equal to 0. Then next find the bn, same as it is 1 upon pi integration of 0 to 2 pi f of theta sin n theta d theta. Then separate the integration by part, a is the constants, then find out the bn is equal to a upon n pi minus cos n pi plus cos theta plus cos 2 n pi minus cos n pi. Then put the value 0 or 1, then the value is 4a divided by n pi, it is the odd functions. Then it is a bn value is the 4a upon n pi. Then next is the even functions. The even functions is the value of functions that the same, then equal distance along the x-axis in the opposite in directions. That means opposite in directions f of minus theta is equal to f of theta, we will see here, or we will speak in the f of minus theta is equal to f of theta. This is the f of theta. Blue line indicates that this is the functions of even functions. It is directions of same side or the opposite directions on the x-axis. Then Fourier series of the even functions f of theta can be the cosine form. We write here f of theta is equal to a0 plus summation of n is equal to 1 raised to infinity a n cos n theta, and the Fourier series of the odd functions f of theta is expressed in the sine form. F of theta is equal to summation of n is equal to 1 as to infinity bn sin n theta. Then find the Fourier series for the triangular waveform. Then are the periodic functions. Show here diagram in the triangular form 0 to t upon 4, t upon 2, 3t upon 4, t. Then minus t upon 2, minus t upon 4, minus 3t upon 4 like this. Then f of t is equal to t when minus t upon 4 is less than is equal to t is less than is equal to t upon 4, and f of t is equal to minus t plus t upon 2 when t upon 4 is less than equal to t is less than is equal to 3t upon 4. Then find out the periodic functions, is it even or odd. This is the odd functions, but an is equal to 0. Then bn is equal to 2 upon t 0 to t f of t sin 2 pi nt n divided by t into t dt. Then 2 upon 2 is the common, this is 2 into 2 4, 4 upon t integration of 0 to t upon 2 f of t sin 2 pi n upon t t into dt. Then find out next 4 upon t, 0 to t upon 4, like this t sine 2 pi n divided by t into t dt, plus 4 upon t, this is the integration separate 0 to 2, that is 0 to t upon 4, t upon 4 to t by 2, minus t plus t by 2 sine 2 pi n divided by t into t by using the integration by parts rule in these methods. Then we will discuss in the form of Fourier series, like as the example for the sine wave, square wave, triangular wave and the sawtooth wave. Then applications, there is the two parts of these applications. Main parts or the main functions of the Fourier series is the sine functions or even functions and the odd functions. The even functions, we will write this, we will say that it is the cosine series, and odd functions it is the sine series. Then next is the half wave and the full wave rectifiers. The half wave and full wave rectifiers, it is same as that f of t is the sine omega t or sine t, that is the a0 is equal to on rectifier equations, it is same as this is the Fourier series. A1 upon A0 plus summation of n is equal to 1 as to infinity an cos n theta plus summation of n is equal to 1 this as to infinity bn sin n theta. A0 is equal to 1 upon pi integration of minus pi to pi f of t into dt, and an is equal to 2 upon pi f of t cos n theta, and bn is equal to 2 upon pi integration of 0 to pi f of t sin n theta into d theta. This is the equations for the rectifier. By solve these equations or the solve these equations same as like that rectifiers in applications of the Fourier series, like as the triangular waveform, sine waveform and the sawtooth waveforms. We will solve the equations for the Fourier series, even functions, odd functions, Fourier series in the periodic functions, like these equations by solve the equations.